Welcome to the Create and Apply Images lesson. In this lesson, I'll start with the two different image formats that we have and explain the differences between the two. Then I'll talk about the different types of images that you can create. We'll do just a 10,000-foot view of the deployment process and then break it down into manageable pieces. You'll get your first glimpse at the Windows Automated Installation Kit, and you'll see that some of these tools will be covered in other videos, but a lot of them are going to be hit in this one. I'll show you how to create and customize a Windows pre-installation environment, or you might have heard this called a WinPE. Then I'll show you how to create a WIM image. We'll take a deep look at Image X. I'll cover every single switch that this guy has. And then we'll apply a WIM image, and I'll finish up with creating a VHD image. First, the two different types of formats that we have. We have .wim and .vhd. A WIM image can only contain a single volume. So if you have multiple volumes on a server or even a desktop machine, you'll need to have multiple WIM images. But, and here's the important point, multiple WIM images can be stored in a single WIM file. Storing multiple images inside a single WIM file can greatly reduce the amount of storage space that your images take up. For example, if you have a Windows 7 32-bit image and it has all the applications for your marketing department, you put that inside a WIM file. Then you create a second image. It's also Windows 7 32-bit, but this one contains all of your applications for research and marketing. When you put that image into the existing WIM file, which I'm going to show you how to do in a few minutes, single instancing makes sure that the same file is not stored redundantly. So every single file you're going to put inside that existing WIM file is checked. If it already exists, like your core 32-bit operating system files, it doesn't store them again, it simply puts a pointer to that file. You can also service your WIM images offline. What's nice about that? Well, you can mount an image, apply whatever patches have come out, and then unmount the image, saving your changes, and your image is ready to be deployed. Now, in the past, the way we handled that was you would deploy an image to a machine, patch that machine, and then create yet another image. So you ended up with all these images out there. The ability to service your images offline helps you apply patches quickly and easily. The second type of image format is a VHD, or a virtual hard disk. And the interesting thing about a VHD is it can contain an entire hard drive that has multiple volumes, where the WIM can only have a single volume in each image, but a WIM file itself can contain multiple images. A VHD can only have one image in it. There are a few different types of images that we can use as well. There are thin images, and normally when I talk about a thin image, I'm talking about an image that contains the operating system and that's it. This has Windows 7 32-bit in it, and the profile's configured the way I want it for all my clients. Then, if you have applications that need to be deployed, you can use some other tool to deploy those, like Group Policies, or Microsoft Deployment Toolkit 2010 Update 1, or System Center Configuration Manager, or if you like, you can manually install your applications. Then we have a thick image. A thick image contains, of course, the operating system, but it also contains applications, packages, drivers, everything you need for that deployment. One of the biggest problems with a thick image is that it's a lot more difficult to make changes to later than a thin image. Hybrid image is something that's evolved from combining a thin and a thick image. A hybrid image contains an operating system and usually your corporate approved applications, things like Office 2010 for desktops or hardware utilities for your servers. And then if you have other just one-off applications that need to be deployed, you can go back to the thin image type to deploy those using Group Policy, MDT, SCCM, or manually. Let's take a look at the deployment process. So I have a machine here. It's a bare metal machine, nothing on the hard drive at all. My first step is to install an operating system. I'm going to install Windows 7, and we'll just do 32-bit. Then install your applications, set it up exactly the way you want that machine to look and feel, and sysprep the machine, which will go in and scrub out all the uniquely identifying information for that one computer, and then shut the machine down. Step 2, well, that step is to create the new image. And there's a lot of different ways you can create an image. We could use ImageX, we could use Windows Deployment Service, or even Microsoft Deployment Toolkit 2010 Update 1. But however you choose to generate your image, you do end up with an image that needs to be stored on a deployment server somewhere. Once that image is stored on your deployment server, now you can blast that out to all your target or destination machines. Let's break this down one step at a time. So, install OSs, applications, sysprep, and generating an image of that machine. We have a pretty small environment here at the Wired Brain Coffee, so we're just going to use the Windows Automated Installation Kit, or the Wake tools, to create an image and apply an image. But there's more to the Wake than just creating and applying an image. The first thing you'll notice is we have the Deployment Tools command prompt. Well, this is a special command prompt. It's not like your regular CMD prompt. I'll show you how it's different when we go to the first demo. The tool we're going to use to capture and apply our images is ImageX. Next is the Deployment Image Servicing and Management tool, or DISM. This tool allows you to mount, unmount, and manage your images by injecting drivers or changing Windows components internally, like your firewall. The next tool is the OSCDIMG, or Operating System CD Image Generator, which can take a WIM file and convert it to an ISO for you. Then you can burn that to a CD or DVD. The Wake also contains the Windows System Image Manager, or WSIM tool, that helps you create answer files in an XML format to automate your deployments. We're going to see that a little bit later on. The User State Migration Tool, version 4.0, USMT. This helps you migrate your user's profile, IE favorites, and their documents, along with any application settings you might like to have redeployed on your new Windows 7 machine. Volume Activation Management Tool. This allows you to centrally manage volume activation, but I'm going to put that one off until we talk about KMS, the Key Management Service, in a later video. The last tool I want to mention is CopyPE, and this creates a WinPE working environment so you can create your own WinPEs and customize them in whatever way you choose. Okay, why you should learn these tools. I know they're not easy, and most of them are command line, and the syntax is really vastly different from one tool to the next. But to troubleshoot any of the other tools, yes, MDT, WDS, or Config Manager, you need to know these tools. Instead of wasting valuable hours troubleshooting one of the other tools, if you understand the process and what's supposed to happen at each step of the deployment, you could always use the Wake tools to force the deployment to happen the way you want it to. That way, you can be your company's deployment hero. The tools used to create an image, well, the one we're going to use here at the Wired Brain Coffee is ImageX. We'll install our operating system, drivers, applications, and packages manually to a bare metal machine. If you'd like to start automating so that your deployments are similar or consistent, MDT allows you to deploy operating systems, drivers, applications automatically and packages to bare metal machines. It also, by default, provides a sysprep and capture task sequence that allows you to easily capture an image of an existing machine. With Windows Deployment Service, you can use the WDS capture utility that's built in. Yes, you do have to set it up and configure it to run, but it is built in to use WDS capture to capture an image of a machine. Regardless of which method you choose, every single one of these uses a Windows pre-installation environment or a WinPE. Now, there are a few different reasons why you would use a WinPE. Really, I think it comes down to about 3 different reasons. If you want to deploy an image to a bare metal machine, that means there's no OS on that machine. You couldn't boot it, there's nothing to boot. WinPE allows you to boot that computer and get it connected to the network. The second reason to use a WinPE is you have a machine that currently has an operating system running on it. You'd like to sysprep that computer and create an image of it. But you can't create an image of a machine while the operating system is currently up and running. Kind of be like trying to change the tire on a car when it's going 60 miles an hour down the highway. You've got all these processes open, file handles, lots and lots of activity. So you'll need to boot that computer into an alternate operating system. In the past, that good old alternate OS was DOS. Now it's WinPE. The third reason to boot a WinPE is when you're troubleshooting a machine that won't boot properly. The Windows Recovery Environment, or WinRE, allows you to boot that computer. The WinRE process will look and ensure that your boot files are where they're supposed to be and named what they're supposed to be named. If not, it'll put them where they need to be, name it whatever it needs to be, and restart that machine. So those are really the three reasons why you would use a WinPE. But what is Windows PE? Well, it's a scaled-down version of the Windows 7 kernel. For this reason, you cannot consider it a full-blown operating system. Great big chunks have been ripped out. So it's not really considered a full operating system. It boots into RAM and runs from the X drive. And let's just say you put WinPE on a CD or DVD. You put that in the CD or DVD tray of a machine, booted the machine, took out the CD, and then ran some application that installed into a WinPE. What's going to happen is every 72 hours, your WinPE is going to reboot. And any applications that you've installed in this manner will be dumped. They'll be gone. So that's what I'm talking about. One of the big issues of this not being a full-blown operating system is it's going to reboot every 72 hours, and applications that you've installed in that manner will be gone. It is a command line interface only. In fact, if your applications require .NET, you'll never get them installed in a WinPE because .NET doesn't exist. You can convert a WinPE to an ISO. You can put it on a CD, a DVD, or you could take the equivalent files and put them on a USB flash drive or even an external hard drive. The one thing you're going to need is a technician machine to create a WinPE. This is what WinPE looks like if you haven't seen it. Notice we're at the X drive, and the command prompt is all you're going to get. A few tools that are there by default for you. The one great big utility you need to learn when you're playing with WinPEs is WPE-util. Now notice the commands that WPE-util runs. A few of them I've noted for you. WPE-util space shutdown, typing that in exactly as shown will shut down that WinPE. I'm sure you can guess what reboot would do, and enable firewall. The one big thing I want to point out is notice on these switches. There's no dash, there's no /. If you put either of those in, you'll break the command. So it's a little bit different when adding your switches. Now a few other commands that are there by default. You've got regedit.exe. We have netsh, the network shell that allows you to go in and manipulate your TCP/IP stack. You can set your client to be a DHCP client or configure it to have a static IP address or a specific DNS server. And the last tool I wanted to talk about is the diskpart tool. If you're not familiar with diskpart allows us to carve up a hard drive into multiple volumes or partitions, along with a few other things. Now this version of WinPE is version 3.0, and there are some special things that happened with 3.0. First of all, XML scripting support is built in, so now when you boot your WinPE, you can run XML scripts by default. There's no more prepping of the WinPE. Well, prepping, if you're not familiar with what we used to do with the old WinPE 2.0. Additional packages that would allow back then for XML support, WMI scripting support, and some other flavors of scripting. They were inside the WinPE. So when you were done turning on the packages that you wanted to have support for, you would prep that WinPE. Well, prepping actually broke other things later on with that WinPE. So now we don't prep any longer. Now we profile. But there's one more cool thing. Our scripting support packages are no longer inside the WinPE. They're stored externally, and you would install each one individually, which I'm going to show you how to do a little bit later on. The biggest improvement is the deployment image servicing and management, DISM replacement. DISM actually replaces Package Manager, which allowed you to add packages to your images. International Settings Configuration Tool allowed you to add language packs, and Windows PE Command Line Tool. Now, each one of these command line utilities had different syntax, different ways to run them, and it was just a really huge ordeal to try to learn what you had to do to run Package Manager versus International Configuration versus PEIMG. So Microsoft decided to make it a little bit easier on everybody and replace all of that functionality with DISM. And I'm going to hold off on DISM for now because the entire next video is on DISM. Let's talk about that technician machine and its requirements. First, your operating system can be Vista, SP1, or later. It doesn't have to be a server operating system, but I usually suggest if you have a server, go ahead and set up the technician machine on a server operating system. It'll make it easier later to integrate with other tools. If you're going to want to create CD images on CD and DVDs, well, of course, you're going to need a CD and DVD burner and image burning software. If your technician machine is a Windows 7 machine, that's built right in. And what makes it a technician machine is you've installed the Windows Automated Installation Kit, or Wake, version 2.0. This is a free download from Microsoft, and the required software for installing the Wake is actually included in the Wake. You gotta love that. No hunting and digging around trying to find .NET Framework 2.0, MS XML 6.0, or MMC 3.0 snap-in support if you're installing on Server 2003. Once you have the Wake installed, now you can create your own WinPE. To create a 32 or a 64-bit WinPE, we're going to use the copy PE command. To create a 32-bit, you would type copy PE space x86 space and then the path of a folder that does not exist. If you wanted to create the 64-bit, you'll just replace x86 with AMD64. Once you have a new WinPE, you can copy that and put it into the ISO sources folder, and it must be named boot.wim. Then we'll point to that folder and create a bootable ISO using OSCD-IMG. And there's one thing you need to know. The one tool you're going to use 90% of the time when you've booted into a WinPE doesn't exist by default. You're going to have to add ImageX to your WinPEs. Let me show you what it looks like to create your own WinPE. On my deployment server, I'm going to launch the Deployment Tools command prompt. Now this looks a little bit different than your regular command prompt, and that's because I've gone in and changed the colors. The first time you open the Deployment Tools command prompt, it's going to have the white text on the black background, just like every other command prompt that you know. But there is one great big difference between this and a normal command prompt. If I type in ImageX at a normal command prompt, it has no idea what that command is. Watch what happens when I type it into the Deployment Tools command prompt. Oh, I get the help file. That's because the Deployment Tools command prompt edits the path statement in your environment variables so that it includes the path where all of these utilities live. If you didn't include that, and you wanted to use your regular everyday command prompt, which I can't imagine why you would have to give it the complete path, and it's not pretty. It's a big, long, ugly path starting with C, program files, Wake, and then whatever your architecture is, tools. It could take you a long time to type these, and I promise some of these commands are long enough without having to type the path to them as well. So I'll close your everyday command prompt. And back over on our Deployment Tools command prompt, let's clear this screen. First thing I'm going to do is create my WinPE environment. So copy PE, I'm going to do a 32-bit version, and I'm going to put it into a folder that does not exist. If the folder already exists, this will error out. Press Enter, and it takes just a second for this to copy over the files needed. If I open Windows Explorer and expand my C drive, go to the WPE folder, you'll see that I now have a file named winpe.wim. Well, that's my winpe. I also have etfsboot.com. I'm going to hold off on that. I'll tell you all about it later. I have a mount folder. It's a convenient folder that's empty by default that allows us to mount our images into it. We also have the ISO folder, which contains all the files needed to create a bootable ISO. I'll minimize Windows Explorer for now because we are going to come back and use that in a bit. And let's go back to our brand new WinPE. Let's do a directory listing. That's our WinPE, and the first thing I need to do is I need to mount that WinPE because I need to add ImageX to it. Mounting and unmounting WinPEs is done with DISM. So the command is going to be DISM /mount-wim. The WIM file is going to be C:\WPE winpe.wim. And because I can put more than one image inside a WIM file, I have to tell it which one I want to mount. Now, you can only mount one image at a time. Even if there's only one image, as there is in this WinPE, you still have to tell it that it's going to be image index, yes, that's index, #1. Then we tell it the mount directory that we'd like to put it into, which will be that WPE mount folder. You'll notice mounting a WinPE is a whole lot faster than mounting a Windows 7 image file, probably because it's about 1/10 the size. When the operation is completed successfully, I'm going to pop back over to Windows Explorer and show you what's just happened. In the WPE mount folder, you now have program files, users, and a Windows folder. This is what it looks like to mount an image. And you'll see the first time you mount an operating system image, you'll have the same folders. There's a couple extra ones, but you'll have these exact same folders as well. The contents will be different, but you'll have the same folders. I mentioned that ImageX is not in our WinPE by default, so we're going to put it in there. I'm going to expand the C drive, expand program files. Let's maximize the screen and scoot this guy over because we're going to go down a bit. Then we'll go down to the Wake where I've installed the Windows Automated Installation Kit. Tools. Scroll down. The 32-bit version of ImageX. I'll copy that. Close Program Files. Go back down to my WPE Mount folder, and I like to put it in the Windows folder. Just right-click and tell it to paste. You have a custom WinPE now. It contains ImageX. The next step, we'll close Windows Explorer, and we'll go back to our Deployment Tools command prompt. The next step is to unmount our image. Well, I already mentioned that we're going to use DISM to do that. So we'll type in DISM and then unmount WIM. Tell it the mount directory. And error 87. This is exactly what you want to see. In the past, we used to use ImageX to mount and unmount our images. And if you weren't careful, you could actually mount an image, make all kinds of changes to that image, and then unmount it and forget to save your changes. The tool allowed you to do that. DISM won't allow that. With DISM, you have to tell it specifically, do you want to commit the changes or do you want to discard the changes? So if I simply arrow up, space, tell it to commit my changes, now when it unmounts, I'll have ImageX stored in it. Of course, if I would have chosen to discard my changes, ImageX wouldn't be there. All right, we've unmounted the image. Now I need to copy that winpe.wim into the ISO sources folder, and I have to name it boot.wim. This is going to make sense when you see the oscdimg command I'm going to run. So copy winpe.wim into WPE ISO sources and name it boot.wim. All right, he's copied in there. Now I'm going to point to that ISO folder and tell it that whatever it finds in that folder, create an ISO for me, and I want it to be bootable. I'm going to use oscdimg. And I'll explain this command in a second. Let me get it typed in first. All right. What I'm telling it is, use the oscdimg operating system CD image creator. Within that image, allow long file names, that's -n. Grab all the hidden files, that's -h, and make it bootable, but not just any kind of bootable. I want it to be El Torito file system bootable. And do not put a space in between the -b and etfsboot.com, or you'll break the command. Then I have to tell it what folder to go look into. I'm pointing it to the WPE ISO folder. Whatever it finds there, I want it to create an ISO named winpe.iso and stored in the WPE folder. That looks great. When it's finished, I can close that command prompt, go back into Windows Explorer, and I'm going to go down to that WPE folder, copy my new WinPE ISO all the way out to my desktop machine, I've created a new virtual machine. I named it WinPE. And as you can see, it does have a hard drive, but it hasn't been partitioned. There are no partitions, volumes, nothing. This is just a bare metal machine. I'm going to point the CD tray to the ISO folder that I have just copied to my desktop machine. And boot it up. And you now have a brand new WinPE that, yes, when you type in ImageX, it actually knows what the command is and helps you out by displaying the help file for you. I'm going to shut this machine down for now, but we're not done with WinPE. Let's look at actually creating an image. Steps for getting ready to create an image. First, you'll need to install an operating system. That always comes in handy, something to image. Install your applications, drivers, and any packages or operating system patches or language packs that you choose. Then sysprepping the machine, pretty important step. You don't want to blast out the exact same image to 500 different machines. You're going to have lots and lots of problems. So you'll need to sysprep the machine. And you have to be sure that you use the right sysprep. If you're using XP or Server 2003 as your operating system, you'll need to run sysprep with the reseal switch. If you're running Vista or later, you'll use the generalized switch. Sysprep can be found in the Windows folder, System32, and then within the folder Sysprep. It'll be sysprep.exe. I like to sysprep the machine and then shut it down. I don't want to restart the machine because I want a chance to boot it into a WinPE that has ImageX so I can kick off my image creation. When you've booted your WinPE up that has ImageX in it, it's time to create the image. In my example, I'm going to create an image from the C volume. So the syntax for that is within WinPE I would type ImageX, give it the / capture switch, tell it the volume I want to capture, that's going to be C, and where I want to put it, what I'd like to name it, and within quotes, give it a description. Notice that I'm storing this on the local C drive. And don't worry, ImageX is smart enough to know that if you capture an image of a volume, you don't include the WIM file in the image. If you choose to do this across the network, let's say I have a deployment server named DeployServe, and on that server I have a shared folder named Images. So on my client machine, boot the WinPE. From the command prompt, do a net use statement. I've chosen to map the W drive to DeployServe Images. And then the command would be ImageX / capture, still capturing the C volume, right? But now we're going to put it on the W drive, give it a name, and in quotes a description. For example, ImageX, capture the C volume, store it on W, name it win7ult.wim, that's my Windows 7 Ultimate image, and in the description I would give it Windows 7 Ultimate. Press enter, and it'll store it on the server automatically for you. But there is one thing you should know. If you store your image across the network while you're creating it, something called verification gets turned on. There's no way to turn this off, and it will cause that capture process to take a whole lot longer. I always recommend store the initial image locally. Then when you're done, map a drive and just do a file copy to put that over on your image server. It'll be a lot quicker for you. The files that will be excluded from the image by default, well, these make sense when you look at what they're really used for. Your recycle bin, your Hybr file, your page file, the NTFS log, system volume information. These things are not stored automatically or created in that image because they're going to be unique for every single machine. So by default, these will be excluded from the image. You don't have to worry about excluding them manually. Let's talk about compression and your WIM images. We've got a few different switches. Actually, we have three switches you can use. You can use fast, you can use none, or maximum. And I wanted to give you a good idea as to how much space you would save versus how much time it took to squeeze out that little tiny bit of space. So I took the exact same machine and I captured an image of it 3 different times using the 3 different switches. Notice the syntax. I've booted to a WinPE, ran ImageX, capture, compress, and then the switch would be fast, none, or maximum. Tell it the volume is C that I'm going to capture an image of, where I'd like to put it, what I'd like to name it, and give it the description. A Win7 image that I chose none for the compression switch came out to about 4.36 gigs, and it took about 5.50 minutes. A Win7 image with fast compression, wow, look at that, I squeezed out quite a bit more. It's about 2.2 gigs, and it was still under 7 minutes to create. A Windows 7 image with maximum compression. Look at that. I barely squeezed anything out of this guy. 2.097 gigabytes, and it took more than 23 minutes to create. And here's the good news. If you don't use any compression switch whatsoever, fast is the default. Let's capture an image of a Windows 7 machine. I have a virtual machine I've already pre-installed with Windows 7. The first step is to sysprep this machine. So we'll open Windows Explorer, expand Computer, C drive, Windows, System32, highlight the sysprep folder and double-click good old sysprep. Notice your default actions here. You're doing a system cleanup action. This is UBI. It's exactly what you want, but you got to put a check mark in the box for generalize. And I don't want to reboot this machine. I want to shut it down so I can boot it into a WinPE that has ImageX to capture an image of it. So on my shutdown options, I'm going to choose to actually shut down the machine. Click OK, and sysprep takes just a couple minutes to run. When my Windows 7 virtual machine has sysprepped and shut down, I'm going to take a snapshot of this machine. Now, the reason I like to take a snapshot is because this machine now has an operating system on the hard drive. I'm going to attempt to boot it to CD, but with it being a virtual machine, you've got to jump on the escape key in order to tell it to boot from CD instead of booting directly from the hard drive. I'm going to change my CD drive. Go to the desktop. And I'm going to boot that WinPE we created earlier, the ISO file that I copied from my deployment server onto my host desktop machine. Now, we'll power on the virtual machine. And I got it on the first try. Choose to boot CD-ROM. And press any key. I'll maximize that for you. When that machine boots up to its WinPE, let's go take a look at what's on the C drive right now. Wow, nothing. Let's look at the D drive. Aha, there's our Windows folder. Something that WinPE does a little differently than actually booting into Windows 7 is it re-letters your drive letters. So a default installation of Windows 7 gets that little 100 meg partition up front. When you boot into Windows 7, that partition does not receive a drive letter. In fact, it's hidden. The C partition is the one with Windows on it. That's not so when you boot to a WinPE. Booting to a WinPE makes that 100 meg partition the C drive, and the partition where Windows 7 is actually installed becomes D. So, to capture an image, we're going to use ImageX, capture switch. I'm going to tell it to capture the D drive, and I would like to store it on the D drive, and I'm going to name this Win7 ULT for Ultimate .wim. We'll give it a description. This will be our Windows 7 Ultimate 32-bit edition. And press enter. When the capturing progress shows 100%, I'm on the D drive. Go ahead and do a directory listing, and you'll see I've got my Windows 7 Ultimate WIM right there. It's a little over 2 gigs, about 2.2 gigs. Now, I'm going to map a network drive, so net use. Let's just go ahead and stick with W. And I'm going to use the IP address, and the name of the shared folder is Images. GLB Administrator. Okay. Then we'll switch to the W drive, and I'm going to copy D:\\Win7 Ultimate.wim. And that's going to take a few minutes to copy over to my server. While that's copying, let's go back to the slide deck. You saw the steps for sysprepping my Windows 7 machine. I shut it down, then booted into a WinPE that had ImageX and ran ImageX capture. I ended up with a WIM file on my local D drive because I'm in WinPE, right? Now I'm in the process of copying that to the server. While that's copying, let's take a look at ImageX and its switches. The first switch is the append switch. Now I have a Windows 7 Ultimate machine. I've created a W7.wim. I have a server named Server1 with a shared folder named Images. I put my W7.wim into the Images folder. I have another laptop I'd like to make a Windows 7 machine. I install Windows 7, any applications I'd like, boot it to a WinPE, map a drive to Server1 Images folder, and the drive I used in this example is the J drive. Capturing an image can be done by using the append switch as well as the capture switch. So if I typed in image_x/append, I want to append the C volume. I'd like to put it on the J drive, which we know is Server 1 Images folder, name it w7.wim, and give it a description of Cells Applications. And when this command completes, I'll have 2 images stored in that one w7.wim. The next switch is ImageX Export. I'm starting with the same machine. I've got a w7.wim. It's Windows 7 Ultimate Edition. I've got that same Server 1 with the shared folder named Images. I place that w7.wim into my Images folder. I have a new machine that I've installed Windows 7 on, installed my applications, configured them to look exactly like I want all my applications in my environment, and sysprepped the machine, boot him to a WinPE, then run ImageX with the capture switch to create an image, and I'm going to name it cells.wim and store it locally on the C drive. So the difference you're seeing between the append and the export switch is I'm physically creating a second WIM file when I'm using the export switch. Then map a drive, use the same J drive to Server 1 Images folder, and run the ImageX export command, point to the local cells.wim that I created earlier, tell it which image index, there's only one, but you still have to tell it, image index 1, and I'm exporting it to J, Server 1's Images folder, into the w7.wim, and this one's going to be called Cells Applications. So 2 points here. The major difference between the append and the export is export is used when you have 2 existing WIM images and you'd like to put one inside the other. Append is used when you're going to capture an image, and while you're capturing the image, you actually put it inside another WIM file. And the second point is exporting works the opposite direction as well. If you have a WIM image that has multiple images inside, you can export an image out so that you have a smaller image. Think about if you have a WIM file that contains 4 images. Well, that could be rather large. If you exported one of those images, you could get it down to maybe half that size or even a quarter of the size, depending on how large each one of the images are. We have a few more ImageX switches that I want to cover. First is ImageX Delete. We'll delete an image from within a WIM file. ImageX_dir will give you a directory listing of all the folders in an image. ImageX Info will give you information on the contents of a WIM file, like the number of images it contains, their image index numbers, and the description so you know what they actually are. ImageX Commit allows you to commit changes to a mounted WIM image. The ImageX Split command, I think, deserves a little bit more explanation. The point here is you have a great big, 2.5 gig image, and you need to put this on a set of CDs or a couple DVDs. So you might have to chunk up that WIM file to create multiple WIM files, but you also want to be able to put in CD 1. When it gets to the end, it automatically knows to call for CD 2. Gets to the end, it calls for 3, 4, 5. I think you see where I'm going with this. That's the point of splitting an existing WIM file. Now the example I have is a w7.wim. It's stored in the C WIMs folder, and like I said, it's a little bit over 2 gigs in size. I also have an empty folder on the C volume as well, and this one is named SWM. If I run ImageX with the split switch, point to C:\wims, the w7.wim file, and tell it where I want to put the destination files, C:\SWM. I want to name it split w7, and the extension will be .swm. And then tell it the size in megabytes that you would like to chunk this up in. What you'll get, the first one will be split w7.swm, and as you can see here, it's about 598 megs in size. The second one is split w7 2.swm. It's around 599 megs. The third is split W7.3, and it's around 506 megs. And the last one is split W7.4, and it's around 288 megs in size. There are some ImageX commands that have been replaced by other commands. First one is ImageX mount. This would mount an image for you in a read-only mode. The mount RW would mount an image in a read-write mode. Then we have ImageX remount and cleanup for troubleshooting previously mounted images. And the last one is ImageX unmount, which does exactly what you think. It unmounts a mounted WIM file. All of these commands for a Windows 7 or a Server 2008 R2 image have been replaced by DISM. Next, let's take a look at applying an image. If you're going to apply an image to a bare metal machine, first thing you have to have is a partition or a volume. So, step one is to use DiskPart to create a partition. Then, you'll need to be sure you have a WinPE that contains ImageX. Map a network drive over to the server where you've stored the previous image. Copy that WIM image locally, and then apply the image using ImageX Apply Switch. Now, you can apply an image from across the network, but it's going to take 3 times longer, maybe even 4 times longer, depending on your network. But once again, verification gets turned on, and there's no way to turn that off. I talked about creating an image and compression. I also wanted to talk about applying an image and compression because you know what? It just doesn't matter. If you take a look at a Win 7 image that wasn't compressed at all, it was around 4.36 gigabytes, and to apply it, it took 5.33 minutes. A Windows 7 image with fast compression, well, that was compressed down to about a 2.242 gig file, and that took 5.45 minutes to apply. A Win 7 image with max compression, well, we didn't squeeze out a lot of space there, and it also didn't take a lot longer to apply the image. So if you look at those, all of them are under 6 minutes to apply an image. You have to think about the fact when you're applying an image, you're simply doing a file copy. Let's look at the steps for applying an image. I have a new virtual machine that I've just created. It's bare metal. There is nothing on this guy. We'll maximize it. And just to prove my point, I'm at the X drive. If I attempt to go to the C drive, it says I don't know what that is. So step one, I know what I always like to do is clean up a bit. If you think back to when we captured our image of the Windows 7 machine, we captured volume D. Well, one of the requirements of ImageX is that you have to put the image back on the same volume letter that you captured it from. So first thing we need to do is on this bare metal machine, no hard drives whatsoever, we need to set up our partitioning scheme. To do that, we'll use the DiskPart utility. So type in DiskPart, hit enter, and from the DiskPart command prompt, let's tell it to list the volume. I want to see what we already have out there. Our CD-ROM is labeled as the D drive. Well, that's no good. We can't put our Windows 7 image on the CD drive, so we're going to have to change that and then create 2 more partitions. We'll need one partition where we're going to store the boot files. That'll be that little 100 meg partition up front. And then we need a D partition that we can actually apply our previously captured Windows 7 image onto. To change volume 0 currently to a different drive letter, we have to tell it to select volume 0 and then assign letter equal to, and you know what? Anything. I don't care. I just don't want it to be D anymore. So I'm going to assign it to R. Next, we have to create our 2 new partitions. To do that, we have to select the disk that we'd like to create them on. That'll be disk 0. Once we're there, we can tell it to create partition, part for short, primary, and the size is going to be 100 megs. We now have a partition. Let's tell it to format, quick, and the file system is going to be NTFS. Then we need to assign a drive letter. We'll assign this one C. And set it to active. Now we need to create that D partition. So once again, and this is kind of nice, the up arrow works in here. So if I up arrow until I get back to that create partition primary, I'm going to get rid of the size and just accept that command, which will take the whole rest of that available hard drive space and put it into a single partition. Then, of course, we need to format that partition. We'll do a quick with the file system of NTFS and assign the drive letter D. Now this one we don't set to active. We only want the active partition to be the one where we're going to store Windows 7 boot files. At this point we can exit the DiskPart command line utility, and we need to copy over our image that we created earlier to our local C drive. Because watch what happens when I try to go to C now. No problem. In fact, I can go to C and I can go to D. And thinking about this, that file ended up being about 2 gigs in size, and we just made a C partition of 100 megs, so we're not going to be able to copy that to C. We're going to copy it over to the D partition. But we need to map a network drive. Let's just call this one F. That images folder where we stored it earlier. Supply your credentials. Then when we go to the F drive, we see that we have the Win7 Ultimate.wim. That's what we want. So we'll copy Win7 Ultimate Wim to the root of D. When that file has been copied over, let's change back to the D drive, and I'm going to clean the screen up. Now, our ImageX apply command. ImageX, tell it to apply, and the file I want it to apply is stored currently on the D drive. It's Win7 Ultimate.wim. The image index number inside that WIM file, although there's only one, I still have to tell it 1. And then where I want to put it, on the root of D. Once you've successfully applied the image, look at how long it took, 5 minutes and 58 seconds. That was to deploy an entire Windows 7 machine, so really quick stuff here. It's just a file copy, remember. We have our image now applied to the D partition. If I were to restart this machine right now, I'm going to get that nasty can't find boot MGR error message because we haven't put the boot files needed for Windows 7 on that C partition. To do that, we're going to change directories into the Windows folder, and then System32. We'll run bcd boot, and I have to tell it where the Windows folder is. It's going to be on D:\Windows. That will be the source to actually boot my operating system, and I want to put the boot files on C. Boot files successfully created. Now you can restart that machine. Helps when you type this in correctly. It's WPE util reboot. And when this machine comes up again, we'll be running the SysPrep Mini Setup Wizard, so we'll have to give that computer a name and tell it the name of the local administrator account we're going to create and the password that goes along with it. We'll also have to set up a couple other little options like time zone and currency format and language. At the Setup Windows screen, we'll accept the country or region, time, currency, and the keyboard layout. Click Next. The username for this, I'll give it as Megan. And this is, since it's a really small company, we only have a few machines here. The computer name, I'm going to leave it as Megan's PC, so it's something that I know based on user. I know whose PC that is. Click Next. Give it the password. You all know my password, swordfish1, and it is a fishy password. Click Next. Not going to give it a product key. This is just a test machine. Automatically activate when online. Remove that check mark, or you're going to have to input the product key. Click Next. Accept the license terms. Tell it to ask you later about your Windows updates. Time and date settings, already set to Eastern. Click Next. This is my work network. And one last reboot. You'll be up and running Windows 7 Ultimate. And now you have a Windows 7 Ultimate machine up and running. So recapping on applying that image, we had previously captured the image from the D drive, and because we're using Image X, we had to put it back to the D drive. So the first thing we had to do on that bare metal machine was change the existing D drive, which was our CD-ROM, to a different drive letter. Then we could create two new partitions. The first one, it didn't matter what we called it. It could have been J, K, L, M, N, doesn't matter. We named ours, we gave ours the drive letter of R, and we made it active. Then we created that D partition, used ImageX to apply the previously captured WIM file back to the D, created the boot configuration database files needed to boot Windows 7 on the drive that will become the C drive. So in the last reboot when it comes up, now Windows 7 looks at that first volume that's set to be active, that little 100 meg partition we created. That's set to be active. That's where your boot files reside, and it's a hidden system reserved partition. Your C partition is now the partition where your operating system lives and what WinPE thought was D. So you should now have a successfully running Windows 7 machine. The next and last part of this lesson is creating a VHD, or a virtual hard disk file that you can boot Windows 7 from. The terminology is a bit different when we talk about VHDs versus WIM image format files. In a WIM image, you mount and unmount your WIM images, but in a VHD, you actually attach and detach the VHD, or virtual hard disk files. Creating a VHD, now there are quite a few steps here. I'm going to give you the high-level steps and then take you through and show you every single individual detailed step to creating a VHD and booting that VHD to a Windows 7 machine. Step 1, everything has to be done from an elevated command prompt, and the tool we're going to use most of the time is DiskPart. The DiskPart utility allows us to create a virtual disk file. Then we're going to select and attach that virtual disk file. Then create a primary partition, assign it a new drive letter, and exit DiskPart. Then we'll apply an existing WIM image that I've created previously into that new VHD file and attach the VHD file. Next, we'll boot a bare metal machine to our WinPE 3.0 that we created earlier. Again, we're going to run DiskPart. This time we'll create two new partitions. One partition, I'm going to give it a drive letter of R, and it's going to be 100 megs. That's going to be that system reserved partition. The rest of the available free space is going to be partition C. Don't worry about why I'm calling it R right now. That'll make sense when we get into the details. After you've got your two new partitions, we'll copy the VHD file that now contains a WIM image to the new C partition we've just created. And again, we're going to run DiskPart. We'll select and attach that virtual disk file, assign it a new drive letter. Then we're going to run the bcd boot command to set up our boot configuration database to actually boot Windows 7 from this VHD. Let's dig in and get started. This one's going to take a while. I'm on my deployment server, and we're going to start with that elevated command prompt. In fact, I'm just going to go ahead and use the deployment tools command prompt. Clean it up a bit. Step 1 is to start with DiskPart. So we'll type in the DiskPart command line utility, and we're now at the DiskPart prompt. Step 1 is to create that virtual disk file. I'm going to put mine in the root of C and name it Windows 7 U for Ultimate. Give it the VHD extension. Tell it the size maximum is going to be 25 gigs and the type will be fixed. And this step takes a few minutes. It's probably the longest step in the entire VHD procedure. When the new VHD has completed successfully, we're going to select it. Then we'll attach that VDisk file. Now remember, this is the same thing as mounting a WIM image. I'm going to show you a little bit more on that later on. Next, we'll create a partition and we'll make it primary. Assign the drive letter of R, just to pick one randomly. It doesn't really matter which one you chose. We'll format. I'm going to do a quick format with the file system NTFS, and this guy goes really, really quick. When finished with the format, click Exit. And now let's go into Windows Explorer. You'll notice that under Computer, you have a local disk of C, and look at that, you've got a new local disk of R, but there's nothing on it yet. All we've done up to this point is create a virtual hard drive. Then we created a primary partition, formatted it with NTFS, and that's what we're looking at now. We don't have any folders whatsoever open on that. So what we need to do is we need to put a WIM image inside this drive. Close Windows Explorer, back to our command prompt, and I'm going to use ImageX, tell it to apply, and I've got the C WIMs folder. Inside that, I have a Windows7.wim that was previously created also on a virtual machine, so the hardware is pretty similar. There's only one image inside that WIM file, but I still have to tell it apply image index number 1, and I want it to apply it to the R drive. When the WIM file has been applied to that VHD, let's take one more quick peek into Windows Explorer. Now look what we have on the R local disk. This looks more like a mounted WIM file. Looks good. Let's close that down. And back at our command prompt, we're going to go back into disk part. And as you just saw, that VHD is currently attached, so all I need to do here is detach it, but I have to set disk part's focus to be on that virtual disk. So we have to tell it to select the VDisk file, tell it the path, and then we can detach the VDisk and exit disk part. We're done on the server. Now, I can't say this with more importance. Do not, absolutely, no matter what you do not do these next steps on that same machine. Now, we're going to make sure, first of all, that that VHD file, look in Windows Explorer. There's our W7U VHD file, and it's in a share, the C $ share, so I'm going to leave it there. And all the next steps have to be performed on your brand new bare metal machine. I already have a bare metal machine, and this guy is currently booted up into the WinPE that we created earlier. First things first, clean up the screen a bit, and on the new bare metal machine, I'm going to launch disk part. Tell it to select disk 0, it's the only one we have, and we're going to create a partition. We'll make it primary, and the size will be 100 megabytes. Then we want to format that partition, and we'll do it quick with the file system of NTFS. Assign the drive letter of R and set this partition to active. Now we're going to create another partition, but instead of typing all that out, I'm going to hit the up arrow a couple times. Back to where it says create partition primary and the size is 100 megs. I'm going to back that out and just tell it to create a partition primary. Just accept the whole rest of the available hard drive space. Then we're going to arrow up till we find the Format Quick FS NTFS. And up arrow again to find that Assign Drive Letter. There it is. This time we're going to assign this the drive letter of C. And exit disk part. Now we need to map a network drive. And I'm just going to use I for image. I'm going to map a drive to that server where I've stored my VHD file. First thing I have to do is give it valid credentials to connect to it. So tell it your domain, the administrator account, and the password. Once we're there, we can go to the iDrive and copy that Windows 7 U VHD locally to the C drive. And this step can take a while too. Well, it does take a while to get copied over, but once it's there, you're going to go right back into disk part again. Now we're at the disk part command prompt. Let's tell it to select the vdisk file and we need to attach it. Then we want to list our volumes. Now notice volume 0 has the drive letter of D. The label is, that's our CD-ROM. Then volume 1 has the drive letter of R. That's that 100 meg partition we created. Volume 2, that's our drive letter of C. That was the whole rest of that local hard drive on this machine. Volume 3 has drive letter E, and that is the Windows 7U virtual disk that we've just attached. So we want to select the new volume 3, select volume 3, assign it a drive letter. I'm going to assign this one V, and exit disk part. Now, I'm going to change directories into the V drive, the Windows folder, System32. Now we have to tell it that we want to boot from that 100 meg partition. That's where our Windows 7 boot files are going to reside. They don't live there yet, but what we're going to do next is put them there. So we'll run bcd boot v:\/ Windows / S and R:. Okay, so close, and yet it's never going to find the Windows folder. If you guys notice, I misspelled Windows. I'm just going to cursor up once, cruise on over, get rid of the M, and give it an N. So it should read bcd boot, V drive, go to the Windows folder, /S to set the source, and put it on the R partition. Hit enter, and that looks much better. Boot files successfully created. Now, you just need to restart that machine. When Setup restarts your machine, you're now at the SysPrep Mini Setup Wizard. I'm going to go ahead and stick with United States, English, and US for my keyboard layout, and click Next. The name of the machine, we'll just give it Rhonda, and click Next. The password, good old Swordfish 1, and my hand's just going to be fishy. Click Next. We're not going to input a product key now. This is just a test machine, and I'm also going to remove the check mark from automatically activate Windows when I'm online. Without the product key, it can't do that, so it'll just bother me again later on asking for the product key. Remove both of those and click Next. Accept the license terms. Click Next. I'm going to tell it to protect my computer and improve Windows automatically. I'll just turn that off for now. Time zone. I am in Eastern Time. Click Next. And I'm on my work network. We'll let this finalize our settings. And you have a brand new Windows 7 Ultimate desktop machine. So, as you saw, creating a VHD is not an easy task. You're not going to get it done in 2 hours. I'd probably say take a good day the first time you do it. Set that aside for creating your first virtual hard drive. But you've seen step by step now every single detail you must complete and the order they have to be done in order to get yourself a brand new VHD. I mentioned earlier the terminology is a little different when we're talking about VHDs versus WIM files. With WIM files, we mount and unmount them. With VHDs, we attach and detach them. I kind of showed you the hard way to do that on the server. You can also attach and detach through the Disk Management user interface. On my machine, I launched Server Manager, then we'll go into Disk Management, and then right-click Disk Management, tell it to attach VHD, browse to your VHD file. You can also choose to attach in read-only mode. And then when it's time to detach, you right-click the attached drive, and the option will be available for detaching the VHD. Let me show you real quick an easier way to attach and detach your VHDs. Back on my deployment server, I'll open Server Manager. Under Storage and Disk Management, I can highlight Disk Management, right-click, and tell it to attach VHD. Click the Browse button, navigate to the root of my C drive, where we have our w7u.vhd. And if you want it to be in read-only mode, this is a tough one, isn't it? Put a check mark in that box. Click OK. And notice we now have the new R drive. It's been attached. If I go into Windows Explorer, I'll see the R drive. And you can also see that it looks just like a mounted WIM. These are the folders needed for Windows 7. So we can tell that this attached successfully. Close down Windows Explorer. I'll go back into Server Manager, back in Disk Management. If I scroll down to my R drive, right-click, I can choose to detach the VHD. You can also delete the virtual hard disk file after removing it if you choose. We're not going to. It took way too long to create that guy. I'm just going to click OK to detach, and it's done. Now, I know that was a lot to cover for one lesson, but you guys got so much information. We started out with image formats, and we talked about the difference between WIM files and VHD files. Then we hit a little bit on thin versus thick versus hybrid types of images and what you might find in those, and some pros and cons. I showed you a 10,000-foot view of the deployment process, and then we dove right in, started playing around with the Windows Automated Installation Kit. The first thing we did was created a WinPE environment using that copy PE utility. Then we converted our WIM file to an ISO using OSCD-IMG. So you got a little bit familiar with some of the Wake tools. We created a Windows 7 WIM image using ImageX, and then I showed you every single switch you can use with ImageX. We applied a WIM image using ImageX and DiskPart, and the last thing we did is we created a VHD image. You're now armed with the knowledge to create and apply your own WIM and VHD files.